Well, hello again everybody. Well, unsurprisingly, we've still got the Hallicrafter S20R on the bench. And for those of you that watched last time, you'll see that we did actually manage to get a little bit of sound out of this radio when we installed an output transformer. So we are making a little bit of progress with it. So I've just spent the last 10 minutes trying to track down the hum problem with this radio. I'm hoping it comes out on camera. It's actually humming quite loudly at the moment. And what I've actually tracked it down to is actually I think it's a screen grid supply to our RF amplifier, which is fed via this 10k resistor here, which I'm surprised it requires such a big resistor, but yeah, that's what it seems to be fed from. What I'm going to do is I've just got a capacitor here on a clip lead, and what I'm going to do is on the smoothing side, on the lower voltage side of the resistor, I'm just going to input our capacitor into circuit, and hopefully if you listen carefully you're going to hear the hum stop. Okay, can you hear that? The hum's a lot quieter. I'm going to take this away. Now there is actually an RF bypass capacitor which is associated with this supply, and from what I can tell the position of the capacitor is somewhere behind this coil here, but unfortunately I haven't managed to find it, and I don't even know if it's actually existing. If it is there, certainly I can't see it, and I've got absolutely no intentions of removing this coil box here to try to get at it. But as you just heard, what I can do is if I put some capacitance down there, I can get rid of the hum. Now that was actually a 1 microfarad capacitor. If I actually put something in a bit bigger, for example here's a 10, let's put the 10 in circuit, we can actually kill the hum pretty much completely. So now there's absolutely no hum. In fact, the set is now totally silent. Now the set is working. Let me just tune into a station.
What better way to celebrate than watching Singing in the Rain?
Maybe tomorrow at 4 we might be even better.
Home time with Bush and Richie.
With Tesco Mobile.
Quality and coverage with prices frozen throughout your whole contract. Tesco Mobile. Every little helps.
Some headaches are unavoidable, luckily.
So as you can hear, actually putting this capacitor in circuit doesn't affect anything, just like we remove it again. Now strangely enough, you actually seem to get more hum when the radio is lightly loaded. I suspect it's something to do with the amount of current being drawn through this resistor here. But all I was demonstrating is we can cure the hum just by adding some capacitance. Now we can kill the hum completely, but to be quite honest, I actually think a little bit of a hum in a valve radio, it's a little bit of a safety feature, isn't it? If it was absolutely totally silent, I would find that a little bit unnerving, in that I quite like the hum just to tell me everything is functioning. You know, it'd be quite easy to you know, to get caught out and put your hand in it. So I think that having a little bit of hum in the background is a good safety feature in a valve radio. So rather than putting this electrolytic capacitor in, I think we'll just go for this 1 microfarad capacitor. I can just hear a little tiny bit of hum in the background, and it doesn't seem to matter if we turn the volume fully up or fully down. Now the other advantage of putting one of these polyester capacitors in is I don't think they will dry out in quite the same way as an electrolytic will, because these resistors do get quite hot. So I'm just going to bodge this capacitor in for now, and what I think we'll do is at some point in the future maybe we'll revisit that, or maybe install the capacitor in the right place behind here if we ever take this coil box out. Let's face it, that's never going to happen, is it? Now before anybody complains about my crap soldering, this is just being put in temporary. We will actually come back and address this, but I don't see the point in doing, you know, too good a job at the moment. We've still got lots of other problems to overcome, so we will come back and we will make this repair permanent in the future. I'm leaving the legs on this capacitor a little bit longer than we need to, because these resistors here get hot, and I want to try to keep this capacitor somewhere where it isn't going to get hot. Well, I've got to admit, that's actually quite messy even for me, but let's face it, you are used to the low quality of my workmanship by now, so it's going to have to do. Okay, well, we've gone ahead and soldered that in. Let's see if it's made any difference. Well, that's a bit unnerving. The set's actually totally silent.
An instinctive goal. It's a mark of such a clever player. He might, but the body language and...
Well, the hum has totally gone, really. I can't hear anything now. There's just a tiny amount in the background, but that's no more. In fact, it's probably as good as any Valve radio I've ever listened to. So I think we're going to take that as a winner.
That's not the best from the best from... Calabria. First of the second half. And
Can't believe how slow the AVC is on this radio. It really is slow.
and that then was a moment of promise. Yeah, I think he was actually Daniel James, but Calabria.
Well, this is a first. I seem to be pulling in some DX stations for the first time on band free, so that's good, isn't it?
Și față. Nu atinge cu mâinile în timpul folosirii. Nu purta o mască care nu stă fixă pe față. Nu atinge partea din păcat pasă. Campanie de informare susținută de Guvernul
deci aproximativ 22 de... 19 a registrat o creștere de 0,1%, conform datelor provizorii publicate în
sich bis 50 Kilometer lange Testlinie zu bauen, eine höhere Geschwindigkeit zu erreichen, sagte Deng Zhigang. Das Ziel liegt darin,
locurilor fixe existente și al terenurilor preluate cu plată de la alte unități sau de la populație.
Die ganze Welt. China News, China Radio und China TV können Sie im Google Play Store.
Well, I think the next part of the radio circuit we're going to take a look at is the BFO, or Beat Frequency Oscillator. Now, I'm sure that most people who are watching my video today will absolutely know what a beat frequency oscillator is and what it's used for, but maybe some people won't. Now, the purpose of a BFO is to allow carrier wave transmissions to be received. Now, a carrier wave transmission doesn't have any modulation associated with it, so you might be wondering, well, what are these carrier wave transmissions? Well, the more popular name for CW, of course, is Morse code. So a Morse code signal doesn't have any audio associated with it. All that the transmitting station does is it turns the carrier wave on and it turns it off. And the rate at which it switches the transmitter on and off produces, a string of Morse code. Now, if you tried to listen to that on a normal medium wave receiver, you wouldn't really hear anything. You might just hear the odd squeal, and you might hear the change in the background noise as the radio quietens when it receives a transmission, but you certainly wouldn't be able to hear the Morse code very easily. So on an old-time radio like this, the operation of a BFO is relatively simple. All it is another oscillator, and the oscillator, the frequency of that oscillator should be set to be very close to the intermediate frequency, which in our case is 455 kilohertz. And what you'll find is they actually couple in a small amount of the BFO signal into the IF strip, and they usually use that using a capacitor. Well, in this case they actually use something called a gimmick capacitor, which is simply some of the wiring from the BFO is actually just wrapped around the wiring in the IF strip, so it isn't even physically connected with a capacitor. It's actually just coupled, the signals are just coupled across by using capacitance from one wire to another, so there's no physical connection, and they call that a gimmick capacitor. In the case of this radio, I think it's C15. So I think what we'll do next is we'll just set up our signal generator to produce an unmodulated carrier wave, and we'll apply that to the antenna socket of the radio, and we'll listen to it, and we'll try switching on the BFO, switching it on, switching off, and we'll try and adjust the frequency control of the BFO, and hopefully we should be able to hear some audio tones coming out, fingers crossed. So I don't think the BFO on this radio is actually working at all, so what we're going to do is I'm actually injecting a modulated signal at the moment. Let's just see if we can tune that in. There's our signal. Now what I'm actually going to do is I'm just going to turn the modulation off now. So the radio should still be tuned in, and I'm going to switch the BFO on. Now I think this pitch control here should be adjusting the frequency now of the BFO. We should be hearing something. Ooh, this actually feels all a bit precarious, like it's about to fall apart. Of course we've got just wires J hooked everywhere. I'm going to cut that actually. I'm going to cut that before we break it. Now I'm not exactly sure how this coil assembly works in here. It's some form of variable inductor, but I'm not exactly sure what. Nobody looked while I used pliers to undo something. Oh god, I'm an animal, aren't I? Absolute animal. Should be a sackable offence, shouldn't it, using a pair of pliers instead of using a spanner or a nut spinner. Oh, something sprung apart horribly then. Well, let's hope it wasn't anything important. Oh, I thought I disconnected all that. What is still connected? Ah, oh, that doesn't look like a good sign. Well, I do hope none of this was very important, because it's all just fallen apart horribly in my hand. Well, unfortunately, as I actually just took this control out of its can, everything just kind of disintegrated on me. I think it was probably already broken, and it feels actually, the whole thing feels quite fragile. So what I think we've got here is we've got a brass collar which is threaded, and then we've got this steel screw. Now attached to one end of the screw inside here, there's a piece of ferrite material. So what we can do is we can actually screw this thread into the body of this inductor here. So if I screw it down, the piece of ferrite material, it actually moves into the coil, and if I actually unscrew it the other way, it withdraws it. I don't think they'll be able to see into there, but I can see there's a slug of ferrite which is actually going in and out. It doesn't really help that the inside of this tube, it should be round, but it looks as though it's somehow been crushed at some point in the past. It looks as though it was crushed when maybe these wires were put onto it. So yeah, that's how it works. So it's a variable inductor, and the inductance is varied by moving a ferrite core into or out of this wire coil. Now unfortunately I can see that quite a few of the windings have they've already broken off this thing, so we could do with fixing that before it actually gets any worse. And just generally the whole thing is just falling apart. So I think somehow I need to glue all this back together. Yeah, the end piece here, where the actual rivets, where the windings are fastened on, there's like a piece of cardboard, and can you see that? It's all loose and it's breaking apart. I'll tell you what, I'm going to have a look at this under the microscope and just see if I can maybe remelt some wax on it, stop it falling apart any further, and I'll bring you back when I've done that, because I think it's going to disintegrate in front of our very eyes if we're not careful. 17, 18, 19, 20, 94, 95, 96. Right, we seem to have 96 windings there. So I think this is just a simple centre tap winding, so in theory we should be able to unwind this second half of the coil now. 1, 2, 3, 8, 4, 59. So the other winding was 64. What a mess. So you can see on the bench now what we have remaining of our BFO control, because I'm afraid it did just disintegrate into effectively a pile of dust and some windings, and to be quite honest, I think I probably didn't help the situation. Now, interestingly enough, I did actually find a few things out. I was looking at some other pictures on the internet, seeing how this BFO control should have been originally installed, and I could actually see that whoever had taken it out in the past had actually installed it the wrong way around anyway. So that's one of the reasons it didn't work. I'm fairly sure that it's actually a centre tapped inductor, and I'm fairly sure that the centre tap wires were actually broken off before I even touched it, and unfortunately I did also break off one of the wires when I tried to dismantle it all and take it apart. So I'm afraid that was my bad. So this threaded shaft here with the slug of ferrite on the end, that was running up and down this tube inside here, and what it would do is it would pass through the centre of the coil, which was wound onto the tube. So this section is threaded, and if I actually turn the shaft, you can see maybe the slug of material. It's moving backwards and forwards. Now unfortunately it's not moving as far as it should be, because all the threads on it, they're all mangled up here, they're all crushed. So I'm not sure what size this is, but I'm going to have to go and see if I can find a tap and die that will fit this. See if we can run a tap down it, sorry, run a die nut down it and clear out the threads, because there's not really any adjustment range on it. Now actually this part of the shaft didn't actually stick out through the front of the receiver. This is the part that stuck out the front of the receiver and had the knob on it. So I think the idea was you would crudely adjust this to where you wanted it, so it was making the right amount of inductance in the coil. Maybe I don't know, maybe to 0 beat with the 455 kilohertz of the IF frequency. So once you'd actually set that centre position, what you then did, you actually clamped this outer tube onto it when it was in its centre position, and then lock this nut up, and now this is the part that was actually had the knob on the end of it. So what I'm basically saying is you must have to, when you install this and set it up, you must preset the frequency, and then basically you just want to go on the high side or the lower side of the IF of the 455, because as I said earlier, these things work on the sum and difference frequency. So I'm guessing you would want to be able to go on the lower side of the 455 and then go on the higher side of the 455. So I'm guessing you'd probably do that to resolve upper and lower sideband. But I suspect that these receivers probably weren't designed with upper and lower sideband in mind. I would have thought that the main reason for this BFO control was probably just to resolve CW. Now unfortunately the original paper former, it's just disintegrated, so we can't actually use this to wind a new coil onto, so yeah, that's no good. So what I went ahead and did is, as you can see, I've 3D printed a new coil former, and I've created like a little basket area here, which is where we're actually going to put the new wire. And there's actually some holes in this end cap in 3 locations, which is where we're going to draw out the wires which go into the original set of tag strips that were on there like that. Now unfortunately this piece of paper is actually incredibly thin. That's probably one of the reasons that it's fallen apart, and because the limitations of 3D printing, my actual coil former has got a little bit more weight to it, so that will probably throw things off frequency. I would have thought the other thing is looking at the wire, this is about 0.15 millimeters in diameter, but it actually had like an outer silk sheath on it as well, so the wire was actually a little bit thicker than you would imagine. I think that the reason probably for that outer jacket that was wound on it is probably to reduce the capacitance between the windings. Unfortunately, I don't think you can buy this silk covered wire anymore. I was limited to what I could buy from, again, RS Components, so I think I've just got effectively what they call enamelled wire or magnet wire today. So it's not going to have maybe exactly the same electrical characteristics of the original wire. So unfortunately, because of this wire and the former, and probably also just the way that the original winding was wound, because when you looked at it, it was kind of wound in a zigzag from one side of the former to the other. I can't actually recreate that, so it's probably not going to be spot on frequency when we rewind this. But I guess all we can actually do is just have a go. We'll just have a go at rewinding it, maybe see what we get. If it actually oscillates at all, this BFO oscillator, what we can maybe do is put some more windings on or take a few windings off and see if we can affect the frequency, or maybe just try putting a little bit of capacitance on it as well, just to adjust that frequency. So we've got a few levers to pull. Now the other thing is, I've actually been in contact with the Antique Radio Forum in America, where, you know, those guys are obviously more expert on American radios than we are in the UK, and a chap over there called Bob saw my post and saw my video, and he said that if the cost was reasonable, he was going to send me over a replacement BFO coil. So thanks very much, Bob, for the offer of that. That's very kind of you. That would really help me out. But I'm quite intrigued to have a go at doing a job like this. I don't know if it'll work, so let's just have a go. Well, I can remember that you've seen my coil winding machine on many occasions, but what I've actually built this time is to actually hold this centered onto the coil winder. I've got a little mandrel, so we've got an end cap here, and then we've got this, I guess it's an external mandrel. This goes onto here like this, and this is actually centering this this former now. It's going to center it onto my winding machine. So just looking at my notes here, I can see that our inner winding, which goes from the inside of the former to the first centre tap, that's got 64 windings on it, and then the outer winding had 96. So I'm going to have a go at putting that first 64 on. Don't always get it right first time, might go horribly wrong. I'm holding this in a little bit of tissue paper so that the wire slips through my fingers, so that helps me tension it, but I don't want to touch the wire because the sweat, the acidity in my skin or anything that I've been touching, that can get onto the windings, and over a period of time and years it actually eats through the enamel. So try and keep the wire clean if you possibly can. Now starting and stopping is the hardest point of this job, so let's see if we can start. It would help if we tighten the chuck up, methinks. Right, well that was 61. I wonder if I can turn this by hand. That says 62. 63. So there's our 64 windings there. Okay, so that's the inner winding to the centre tap. Now I've got to put the last 96 turns on. Now unfortunately, when I actually took the old coil apart, I wasn't really sure what order the wires went onto the tag strip. So I'm not sure. I know that the centre tap is going to go to the centre connection, which is ground, but I don't know which way round the 96 turn winding and the 64 turn winding go. So I'm afraid, again, just trial and error, just going to have to try it both ways. So here's our newly wound BFO coil with its windings coming out of it. So you can see we've got the white dot for the far end, that's the start of the winding, and that's the double winding there that's got the centre tap point on it. So what would happen is this pushes into here like this. And then what we can do is, if you screw this rod, the piece of ferrite material gets pushed through the coil, it gets pushed into the coil, or gets pulled out of the coil, altering its inductance. Well, that's the theory anyway. So I've got to go ahead and reassemble this now into the radio, and I guess we've just got to give it a try. Maybe it'll work, maybe it won't. Now unfortunately I can't actually get our old tag strip onto my new coil former. This wasn't a mistake on my part, it's just practically how thick you have to print the former, and I couldn't actually print a wall thickness thin enough to actually make this work. So what I'm hoping I can do is, well, effectively just cut this down the middle and split it. And I'm hoping it will then go on to place. Okay, let's just give it a go, eh? Well, that was a close one. I just about stopped myself there from saying I can't see the wood for the trees, but yeah, that's very much the case. It's not snippy snip time, it's Mr. Soldering Iron time. I just don't know why this was done like this. It's as though somebody purposely removed all the components, put them on the floor, stamped on them a bit, and then reassembled it. I just don't understand. So it looks like a fair number of the pins on this valve holder have actually been used as ground straps. So we've got pin 2, 1 and 8. They're all grounded together. Well, I think somebody's managed to get one of the biggest glob of solder on here that I've ever seen. So between pins 1 and 5 we've got a resistor installed, which is 66 kilo ohm. Between pins 1 and 5, 66 kilo ohms. Well, as I'm sure you've come to expect from me, I went ahead and I lost some of the screws earlier, so that makes reassembly easier. Okay, I've reinstalled our BFO coil, switch the power on, let's turn it up. What do we think will happen? Do we think anything will happen? Will we get a squeal from the BFO? Will we get nothing? Will we get smoke? I've got to admit, my bets are on we get absolutely nothing, but yeah, let's have a go. So I'm hoping you can hear that whine. So that whine is our BFO operating. But it does seem like the insertion level for the BFO is too low. So what you'll find is if I adjust this BFO control, it'll be slightly out of step with the IF of the radio. Then it'll come into frequency with the IF and you'll get a 0 beat. And then when I go to the other side of the IF, the frequency will increase again. So what we're going to do is I'm going to adjust it for 0 beat, I think. Well, it seems like there's possibly more than one null point. There's a carrier there. You can just hear a little bit of hiss. It's probably a data service. So let me just switch on the BFO. Well, really, just as I expected at the first go at winding this BFO coil, it doesn't seem to be working as well as I really wanted it to. So I've gone ahead and you can see this piece of wire here, that's just loosely coupled to the BFO circuit, and I'm feeding some of the BFO signal into a spectrum analyzer. So let's take a look. So this is the output from my BFO oscillator at the moment, and it's 865 kilohertz. So the frequency is much too high. So what I'm going to do now is I'm just going to take a screwdriver and I'm going to wind our piece of ferrite into our core, which is a pitch adjustment. So if I wind that down, you can see that the BFO frequency is coming down. And obviously it does couple at some points with the IF. I think we must be getting some harmonics. And the lowest frequency that I managed to achieve there is 636 kilohertz. Well, yeah, unfortunately the IF for this radio, I think it's 550, so we're actually a fair way out. We're about 100 kilohertz out, so I think the only thing to do is actually to have a go at putting a few more turns on this coil. Well, as you can see, I've gone ahead and I've removed our coil again, and I'm afraid it is looking very slightly jumped on. What I think we'll do is we'll just try putting another 10 turns on it, and I've got to admit I don't know whether I want to be putting 10 turns on the outer winding or the inner winding, or if it makes any difference. So basically what I'm going to do is I'm going to put them on the outer winding and just try it, because that's easier than having to take all the windings off and start again. So I'm going to go for the easy approach first. If it doesn't work, we'll have to try something else. Of course, once we've found the right number of windings, what we'll do is we'll take all the windings off and we'll start afresh with it. Okay, well, I just went ahead and I've wound 12 more turns onto our BFO coil, and at the moment, using this dummy antenna, I'm just injecting into the radio at the moment a carrier wave. Now that carrier wave is unmodulated, there's no tone to it, it's just a carrier wave, so it's like the tone from a Morse code key. And you probably can't hear anything at the moment. You can hear a bit of noise in my room, a little bit of whining in the background, but that's just noise in the room. But when I switch the BFO on, you're actually going to hear the actual beat frequency oscillator. That's going to beat with the IF frequency, so let me switch that on. So now if you were trying to receive CW, that's what you would hear. And just to prove that this pitch work controls the BFO, so we can kind of simulate now some Morse code just by turning the carrier wave on and off. Now, of course, it's not unusual in my videos for some shenanigans to creep in now and again, and I'm afraid this video was actually no different. Now, one thing that may not have come out very well on the camera footage is that unfortunately at some points when I was doing the testing, I actually had the BFO coil installed incorrectly. The way that I think this oscillator works is that there's a feedback winding and what I would call an oscillator winding. Well, I think I had the feedback winding taking place of the oscillator winding. So the oscillator winding has much, I think it probably has more turns on it. So the oscillator winding probably needed to have the 96 turns on it, and the feedback winding maybe had the 64 turns on it. So I had those connections reversed, which meant that the local oscillator was operating probably on a harmonic. Now, I'm not sure if that was obvious on the video, but that was the case. But even after I did actually correct it, when I wired it correctly into circuit, it was still not going low enough in frequency, and I had to put another 12 turns on the coil. Now, I think the reason that it probably wouldn't go low enough in frequency is because the original former that I used was made from paper, and the paper former was a lot thinner, so the ferrite material was much closer to the coil. My former that I 3D printed, the wall thickness was a lot thicker on it, so the overall inductance level, the number of millihenries, would have been less for my coil, than it would have been from the original radio manufacturer's coil. So what we had to do is we had to put a few more windings on to make up for that difference. Now unfortunately that story didn't really come out very well on the video, so I'm sorry if that's confused anybody. So I think for today this seems like a logical place perhaps to leave our Hallicrafter radio. Now it's unfortunate that we didn't manage to pick up any CW or SSB today. I did try, but nothing was heard. Maybe the band conditions will improve later this evening. We'll give it another try. Now our Hallicrafter S20R, I think it is probably 90% working now. Of course it would benefit from a full alignment, but that's not a job for today. Another job that I plan on doing in the future is we will have a look at the cabinet and we will do a restoration on that. But again, that's a summer job because it's not painting weather. It's far too cold outside at the moment. So for today I think that'll do. As always, thanks very much for watching. I hope to see you again very soon. Until then, bye bye for now.